Is the dollar shrinking? If you're an American and you've been buying imported products recently, you might have noticed that their prices have gone up. It's even more obvious if you're an American and you've gone abroad in the last 6 months because you've noticed that in relation to other currencies, the dollar has shrunk and so you're paying more when you go abroad. In fact, there are a bunch of news articles recently saying that the dollar has declined more in the last 6 months than just about any time in the last 50 years. And so in the most recent Bamboo Weekly, I asked you to look at data from the Federal Reserve, data that they call H.10, foreign exchange rates, both individual countries and broader indexes of aggregations of these countries to figure out how much has the dollar dropped and has it really dropped faster recently than was previously the case. Now, you can get this data from the Fed, as you see here, but it's also available via FRED, not to be confused with Fed. And the FRED is from the Federal Reserve Bank of St. Louis, and it's this amazing like data candy store if you're into data analysis of like economic stuff. And you can download all sorts of things from here, including individual currencies and these wider indexes. So I asked you to answer a few questions, and we're going to go over the first two here in this video. The first is I asked you to read the data, the H10 data, data that I downloaded from Fred already, into a data frame, and make sure that observation date is a date time, which should then be set to the index. And then based on that, which currencies have been tracked since the start of the Fed's data set, and which was the most recent currency to be added. So I'm going to start with this file name. I'm actually going to start with import pandas as PD. I'm going to say df equals PD read CSV of file name. Read CSV of file name. And this will hopefully do a good job. And we can see that it loads up the data. And sure enough, we have the data. We have here observation date. We have here, right, DTW and DEX. DTW are the general indexes, and DEX means exchange rates with a particular currency. And we have 14,000 rows and 13 columns. Sounds pretty good, right? Except that I didn't do what I asked. Right, I didn't do what I asked in this question. Make sure that observation date is a date time. Is that a date time? I don't think so, because if I say df.dtypes, we're going to see that actually observation date is an object. And that's because even though it looks like a date time here, the fact is that pandas and read CSV will not automatically turn datetime values, things that look like and could be datetime values into datetimes unless we explicitly ask for it. So I'm going to do that here. I'm going to say here parse dates equals observation date. And I give that as a list. It's a list with only one element. And I run this again, and it looks pretty much the same. But now when I run dtypes, you're going to see observation date is a datetime 64. Fantastic. But there was one other thing I asked you to do, which was to set this column to be the index. So I can say index col equals parse dates. And once we do that, look at this. Oh, wait, I'm sorry, not parse dates. Duh, that's the keyword. I want to say observation date. There we go. Much better. And now it actually works. Who would have guessed? And so now I have a data frame in which I have 14,215 rows. The number of rows has not changed. The number of columns has declined by 1 because the column count only includes the regular columns, not the index. And now if I look at the D types, we can see that all of these are float 64. This means that I have a time series. I have a data frame in which the index contains date time values, which is really useful, and we'll see that in a little bit. But it also means that all my values are numbers, numeric, so I can do calculations with them. What sorts of calculations will I want to do? Well, let's see. I asked you two questions here. Which currencies have been tracked since the start of the Fed's data set? Well, how can we find that out? Well, first of all, let's put this into method chaining format here. I'm going to start with df. And then what do I want? Well, I want only the currencies. I'm not interested in all of the sort of indexes that we have. In order to do that, I'm going to have to choose a bunch of columns. And the way we choose columns most easily is with a .filter. And if I say .filter, I can actually filter in a number of different ways. My favorite way to do it is to say regex equals, and I use a regular expression. And if I say it starts with, that's the caret there, caret at the beginning says I want to anchor my regular expression to the start of the string. So this basically means show only columns in which the column name starts with DEX. Now notice, filter has nothing to do with the contents of the column. It has to do with the names of the column. And sure enough, now I have a much skinnier data frame. Only those columns that begin with DEX. Fantastic. But is this giving me an indication of which currencies were there way back at the beginning? No, it does not. However, now I can say .ilock 0. And .ilock means I want to grab the row at position 0. In other words, I could grab it with the first index, 1971-0104. But ilock means I'm going to ignore the actual index, what we would grab with .lock, and I'm going to get with .ilock instead. And that gives me back, because I only asked for one row, a series that I got from cutting across that first row. And here we see a whole bunch of currencies. Each, we have the value of that currency on that first day of trading that the Fed is tracking. But notice that a whole lot of them are NAN, meaning that we didn't track it back then. How can I get rid of those NAN values? I say .drop NA. And now I only have these three currencies, which is the Japanese yen, the Canadian dollar, and the British pound. Okay, so I have those three. What if I want to grab the names and I'm not interested in the values? Well, then I can just say .index. And then I get back the index value, which is just this list of strings here. All right, so now we know which of the currencies have been tracked from the beginning. But then I asked, which was the most recent currency to be added? And that's a bit trickier to figure out. How are we going to do that? Well, we're going to start with the F, and we're going to say .filter of regex equals, we're going to say anchor dex. Okay, so same thing on that front. But now what? Well, here's the thing. What I want to do is find out which was the first index that had a non-NaN value. And I can do that actually with the first valid index method. If I run first valid index on dex USEU, it's going to give me wherever it was non-NaN, the index there. So that sounds great, except that I want to do it for one column. I want to do it for a whole bunch of columns. So I'm going to say here, apply. And apply allows me to run a function repeatedly on a bunch of rows or a bunch of columns. Now, in this particular case, I want to apply to each of the columns. So I'm going to say here, apply. And what function am I going to give it? I'm going to give it an anonymous function, lambda c underscore. And that just means basically c underscore. I know I'm getting a column one at a time. And so I'm going to call c underscore to indicate that it's kind of temporary. And then I'm going to say c underscore first valid index. And I'm going to grab then the first valid index for each column. On which date did we get the first valid element? On which index did we get the first valid element? And then I'm going to say here, axis equals rows. Now you might be saying, wait, axis equals rows. Why would we be doing that? Aren't we doing it with the columns? And the answer is, it's a little counterintuitive, but we wanted to sort of find for each column, so we say axis equals rows. I like to think of it as saying that basically we're going to get a new row with each of the indications, each of the first indexes. And if we run this, look what we get. For each column, we indeed get, like you can think of, again, an additional row, one element for each column, showing us which currency appeared on which date. Yeah, but I want to know which is the most recent. So you know what I can do? I can say here, sort values. And sort values will sort them from lowest to highest. And we can see then the most recent currency that the Fed is tracking came into effect on the 4th of January, 1999. And that was the euro. Not a big surprise if you're a fan of monetary policy. But if you're not, on occasion, you might need to be helped by this sort of thing. Okay, so that was the first set of questions. The second question says, the New York Times article says, the dollar is off to its worst start to a year in more than half a century. So what I want to do is, just since 2020, calculate the percentage drop in the broad index, DTWEXBGS, for the first 6 months of each year. How in the world are we going to do this? Well, let's start off with saying DF. Good start, right? And then I'm only interested in data from 2020 and onward, and I'm only interested in the DTWEXBGS column. So I can say .lock. I'm going to say, watch this, I'm going to say 2020 colon. What in the world? What is that? Well, because our index is a time series, because it contains date time values, I can put in a string here a date or a portion of a date, and I can use that either to retrieve an individual value or set of values, or I can use it in a slice. And if you leave off more detailed portions of the date time, then the rest are wildcards. So by saying here 2020, I'm saying any value from 2020, okay, doesn't matter what month, doesn't matter what date. And if I put it in a slice here with a colon, that'll get me all the dates, all the data from 2020 onward. That's great, except that I don't want all the rows. I don't want all the columns. I just want the column DTWEXBGS. And remember that I can use a two-element, let's close this also, two-element or two-argument version of .lock is row selector and column selector. So I'm saying I want all the rows in 2020 and onward, and only this column. If I do that, blam, now we've only got a series. Yeah, but now we still got some work to do, because I want to find out how did we do in each year, and not just in each year, in the first half of each year. Well, first of all, let's just get rid of the NaN values. They're just going to annoy us. And then what I'm going to do is I'm going to say dot reset index. Why in the world am I going to do that? Because when you reset the index, you move it from the index into a column. So now I have a 2-column data frame with observation date and our index. Let's say the currency index, not our data frame index. Now what? Well, I'm going to want to keep track of the year and the month so that I can actually find things. So I'm going to say here dot assign, and assign allows me to temporarily add a new column to a data frame. So I'm going to say year equals lambda df underscore of observation date dot dt dot year. That pulls the year out from each element and gives us a new column called year with the year from there. And then I can say here also month equals the same sort of thing, lambda of df underscore of observation date dot dt dot month. And if I just stop there, we're going to now have a data frame with 4 columns: the original observation date, the index, the monetary index, the year, and the month. Why do I want that? Well, because I'm going to do 2 things. First of all, I am only interested in the first half of each year, right? I'm only interested in where the month is less than 7. So I'm going to say here dot lock lambda df, and I'm going to say df of month, the thing we just created in the previous line, is less than, or I can even say this, I can say dot is in range of 7. Pretty sneaky, huh? So is in is a great method that allows me to say, I want these values to be in this list, in this range, and so I give it a range of 7. And suddenly, if I do that, it's not very happy. Oh, because I said df and not df underscore. Do that all the time. There we go. So now we only have months 1 to 6, right? In other words, we only have months January through June, okay? And we have any year we want. So far, so good. But now what are we going to do? Now I'm going to group by. I'm going to say group by on year. For each year, let's find out what the BGS value was, and we want both first and last. In other words, give me the first value at the beginning of that 6-month period and give me the last value at the end of that 6-month period. Now, I will tell you already that if you look in the documentation for Pandas, it will tell you don't use first and last anymore. And they're probably right, but it's so convenient in this particular case. And you can see then that I now have for each year the first value and the last value. We're getting closer, right? We're getting closer because now we're getting closer to be able to figure out how well or poorly did the dollar do in each of these years. Yeah, but I want to know how well or poorly. So I'm going to run now percent change. And I'm going to say axis equals columns. Why? Remember, when you say axis equals something, it's because I want a new of that. So I want a new column. I want to get for each row here a new output saying, basically, how did we do from first to last? And so I'm going to get now what happens is it actually gets rid of the first column, turns those values into NaN. And then for the last column, this is what we really want. So now I just want last. And this will tell me then for each year how well the dollar did from the beginning of the year to the end of June. And if we want, we can then do a sort values again and see how well did we do. And sure enough, 2025, this year, it is the worst of the last number of years, right? Did pretty poorly in 2025, pretty poorly in 2023, pretty poorly in 2021, although in 2021, in 2020, it was like almost stable. And then the others, 2021, 2024, and 2022, things actually, the dollar got stronger a bit. Is that a big deal or a small deal? It actually depends on what you're doing. If you're importing, if you're exporting, if you're traveling, if you're not traveling. But the fact is that the dollar has gotten weaker, and it's gotten weaker than at any time, certainly in the last 5 years, and according to analysts who've looked at the larger data set, in the last half century. All right, I hope this was really interesting and useful for you to see how we can work with real data sets. Don't forget that I have problems and questions like this every single week in Bamboo Weekly. You can check that out at bambooweekly.com. Let me know what problems and questions you had with this or with any Python or Pandas issues, and I'll be back real soon with lots more videos about Python and Pandas and everything in between. Thanks for watching. See you again soon.